Okay, I had a request for a little homework example here from section 8.2, number 7. So we're going to work this one out together. If you want to follow along, it's very much like number 5. So if you didn't get number 5 and number 7, this is an instructional video to show you how. So on number 7, we're going to perform the following steps to minimize g equals 4x plus 2y. We're going to save that one for later. We do not graph it. We don't do anything with that until we have the corners of our region. So first we need to get the corners of our region. It says x is greater than or equal to 0, y is greater than or equal to 0. So I just drew the first quadrant here. We also have x plus 2y is greater than or equal to 15. So I'm going to solve that equation by subtracting the x over to the other side and then dividing by 2. So this will be y is greater than or equal to negative 1/2 x plus 7.5. So we're just rearranging it so we have y equals because that's easier to graph. So I'm going to start off at, let's say this is 5, 10. 5, 10. So I'm going to start at 7.5 because that's my y-intercept. And go down 1 over 2, down 1 over 2, down 1 over 2. So 7.5. The other thing you can do is find your intercepts. So to find your x-intercept, you put 0 in for y. Let's do it that way. So we subtract 7.5 over to the other side, and then times it by 2. So this will be at, not negative. At 15 is where my x-intercept is. So I'm going to make this a little bit longer over here. So 15 is my x-intercept. And if you put 0 in for x, then this number here is your y-intercept. So 7.5 to 15. Let's draw that graph. Now, if I were to shade it in, it was greater than or equal to. So that one would be shaded above. So I'm just going to really lightly and quickly kind of go like this. Okay, so if it was colored in, it'd be colored above. Now we got to do the next one, which is on my book here. X plus y is greater than or equal to 10. Well, if I solve that one, I'm going to subtract the x. So I'm going to start at 10 and go down 1 over 1. So that means it's going to meet up. Start at 10 on the y-axis. It's going to meet up at 10 on the x-axis. So it looks like this. And it is also greater than, so it's going to be shaded above. I'm going to shade this direction just so that my shading kind of crosses. I get little crosshairs. I like it that way. So there's a lot of regions of this graph because we have the zeros are a boundary in the red and the purple. Because the red and purple are both above and the zeros are above, the region of the graph that we are talking about is, let's see if I can highlight it for you. Up here. I was hoping for a little bit bigger highlighter, but that's okay. So all of this section is my solution set. And obviously we don't want to name any points or anything, but that's the region we're looking for. That's the first step. Graph the region and identify the corners of the region. So for part A, didn't even write that, but part A is the graph, which we have done, so I'm not going to move it or anything. And the corners of this region, well, the region is the yellow part. So up here, it's infinity. There's no upper corners. This still is a corner, though, because right here. So one of the corners is at the point 0, 10. Corners. The point where they intersect, which I'll get to in a second, and this point here, which is 15, 0. And then the one where they intersect. So the point where they intersect is where the two lines meet. So since we solved them both for y, we had this line, and we want to know where they're equal. So I'm just going to take these two equations and set them equal to each other. So negative 1/2 x plus 7.5 equals negative x plus 10. Let's add 1x to this side. So if I have negative 1/2 plus 1, then I get 1/2. And if I subtract 7.5 over here, I get, oh, there's an x there. I forgot the x. 2.5. 2.5 divided by 0.5 is 5, so x equals 5. So the place where these cross is at 5 comma, and to figure out what the other answer is, I could plug them into either equation. Easier one's probably the red one here. If I plug in a 5, I get a 5. So 5, 5 is the point that they both go through. I'm going to add that to my list over here. So these 3 points are my 3 corners of my shaded region. And then for part B, I think all I need to do is probably plug them into that very original constraint function. So let's see. Part B, test the objective function at each of the corners to determine which corner gives the minimum. Give the minimum value and the x and y. So basically, I'm going to take that g equals 4x plus 2y, and I'm going to plug each of these points in. So when I plug in a 0 and a 10, I get 20. When I plug in for x, I'm going to plug in 15. And for y, I'm going to plug in 0. 4 times 15 is 60. And in the third one, it's 4 times 5 plus 2 times 5. So that's 20 plus 10, which is 30. And so what they wanted on this one was a minimum. So the answer is going to be the minimum is 20. And they also want the x and the y that give that value. So I usually just say at 0, 10. So here's your x, here's your y, and here's your minimum. This right here is the final answer. Now, obviously on these problems, you're going to have to show some work because just getting that answer is not really all you have to do. You have to find all the points, plug them all in, and see which one is smallest in this case. So read the directions. Sometimes they want the min and max, sometimes just min, sometimes just max.